Okay, welcome everybody. In this video we're looking at part 2 of trapezoids and kites. So we're mainly focusing on kites in this section. So let's take a look at a kite. It's a quadrilateral with two sets of adjacent congruent sides. So let's draw a kite here. The two adjacent sides are congruent. Okay, so a dart is also a type of a kite. It is a kite that is concave, as we see here. Here's an example of what a dart looks like. So here are the parts of a kite. We have two vertex angles and two non-vertex angles. The non-vertex angles are congruent, and the vertex angles share the congruent adjacent sides. Kite theorem number 1. The non-vertex angles of a kite are congruent. So let's draw a kite here. Here are the adjacent and congruent sides. Here are the non-vertex angles, and they are congruent. Kite theorem number 2. The diagonal through the vertex angles is the angle bisector for both angles. So let's make another kite. So here are my vertex angles. If I draw a diagonal through them, it will bisect the angles. Just show the congruent symbols here. Kite diagonals theorem. The diagonals of a kite are perpendicular. So let's make another kite. I draw the diagonals. They intersect at a 90-degree angle. Okay, so let's look at some examples. Example 5, find the other two angle measures in the kites below. So in part A, we're given the vertex angle of 130 and 60. But we know the non-vertex angles are congruent, and we also know that the quadrilateral's interior sum is 360. So we can say that 2x plus 130 plus 60 equals 360 degrees. I get the 2x because I have two non-vertex angles. So now we can combine like terms, solve for x. Get 2x equals 170 divided by 2, x equals 85. So those are my two unknown angles. They're both 85. Part B, I know one vertex angle is 90. I know that one of the non-vertex angles is 94, so that must mean the other is 94. Again, I know that the quadrilateral sum is 360. So I can come up with an equation and solve for x. Now you get 82 degrees. Example 7. Determine what type of quadrilateral rstv is. Simplify all radicals. Okay, so if rv equals rs and vt equals st, then that means that the two adjacent pairs are congruent, and we could have a kite. However, we can't have rs equal st because we would end up having a rhombus at that point. All the sides would be congruent. So let's find the distance of rv and rs and see if they are equal. So I have the distance formula here in red, and I'm going to substitute my coordinates for x1, x2, and y1, y2 here. You can read the coordinates off of the graph on the left. And I end up getting square root of 50, which simplifies to 5 root 2. So let's take a look at RV. And it would be -4 minus a -5 squared plus 0 minus 7 squared. simplify this, I also get 5 root 2. So RS equals RV. So far we're in good shape. Now we need to prove that VT and ST are congruent. So I'm going to substitute the coordinates into my distance formula, and I get root 90, which simplifies to 3 root 10. And the distance between S and T I'm going to find now. Now if it equals the same thing, then we know that these two sides, adjacent sides, are congruent, and they are. So we just have to show here that these two sides, adjacent sides here, RS and ST, are not congruent, which they're not. 5 root 2 is not congruent to 3 root 2, so rstv is a kite. Okay, so let's finish this up. Example 8, determine what type of quadrilateral ABCD is. So I have 4 points here. Let's plot the points. Now this does not look like a kite to me, but this section is also about trapezoids. And so let's see, if we have one pair of parallel sides, then we know we've got a trapezoid. So slopes are going to be the same for parallel sides. So it seems to me that the slope of BC and the slope of AD might be equal. So let's check. Going down 6 and over 3 simplifies to negative 2. That's our slope for BC. And the slope for AD, we're going down 8 and over 4. So negative 8 is our rise and 4 is our run. We get negative 2. So the slopes are the same. Slope of AD is parallel to the slope of BC. So I'm going to put my parallel symbols here. So it's a trapezoid, but maybe it is an isosceles trapezoid. If the legs AB and CD are congruent, then it's an isosceles trapezoid. So let's do a check here. Let's use the distance formula to see what the length of AB is. So I'm going to use the coordinates here and plug it into my distance formula, and I get root 20, which simplifies to 2 root 5. And let's find CD. Substitute my coordinates in the distance formula, and it doesn't look the same. I think it's going to be slightly larger. We get root 25, which is 5. So AB does not equal CD. It is not an isosceles trapezoid. It's just a regular trapezoid. So these last couple of problems require a little bit of work. Make sure you show it. Hopefully this section makes sense. Go ahead and try the practice set. See you next time.